Okay, hello IBHL, this is Miss Kosh. So there was a question on how to do part B of this problem. So first of all, hopefully you remember how to get the partial fraction, how to break that into partial fractions. Go watch a different video or let me know if you have questions on that. But the answer to part A, I have included right there for you. So what we need to do is we need to write this in a way that we have some value out front, so like k times 1 plus bx of somehow that's raised to the r power or to the n power n power. So that's kind of our goal for each of those terms. That's a little messy. Sorry. Let me show you the actual problem. So this would be 3 times 1 plus x to the negative 1. And since this value right here is already 1, we're good. Okay, so we like to make that a value a 1 so then we don't have to raise it to other powers later and life is grand. So then we want to work on the next part. So this becomes a minus 2 times, well, a negative 2 plus x to the negative 1 power. Notice that was on the denominator. Well, this one is not quite so satisfactory. I want this part right here to be equal to a positive 1. So what I have to do is, hang on, let me get rid of that yellow. What I have to do, this is fine. So it just sits there fat, dumb, and happy. And then I have a negative 2. I'm sorry, I really like to say that. And then I need to factor out a negative 2 from this one. And that would give me a 1 minus x over 2 if I distribute that back. And this is all raised to the negative 1 power. Let's make sure. That gives me a negative 2. When I distribute back, that gives me a positive x. Okay, so we're not done yet. We still have this sitting here, fat, dumb, and happy. And then I have a negative 2 times, well, this becomes a negative 2 to the negative 1 power times 1 minus x over 2 to the negative 1 power. And to be honest with you, I don't need these brackets anymore because everything's multiplying. And so then I get a, well, what do I have? I have 3 times 1 plus c, still sitting there, oh, fat, dumb, and happy. And then I have a minus, and I have a 2 times, well, this is a 1 over a negative 2 times 1 minus, x over 2 to the negative, okay. This, a negative, I'm looking at, when I say this, I'm looking at this and this. Those negative times negative is a positive. The 2 on top and the 2 on the bottom cancel each other out. And so I have 3 times 1 plus x to the negative 1 plus 1 minus x over 2 to the negative 1. I think that was what I got on my answer key. I'm checking on the computer right now. Yes, that's what I had. I had written negative 1/2 instead of x over negative 2, but that's fine. Okay, so what I need to do now is do the two different sigma notations. So this is going to be equal to 3 times the sum as r goes from 0 to infinity, because this is raised to a, if this value here were a positive integer, then we would have a particular number of terms. We would know what that looks like. It's not. So we need to have an infinite sum instead. Okay, and so this becomes, what is it? It's the exponent in choose r, and then this becomes x, whatever that b value is, raised to the r power. Okay, and then the next one would be, well, there's one, it's just the sum as r goes from 0 to infinity of negative 1 came from right here, choose r, and then this becomes a negative, we could say 1/2 x, I think is how I wrote it in my answer key, raised to the r power here. Okay, so we have these two things. They're infinite series, and they tell us, I think, that they want 4 terms. So we're going to do each one of these, we're going to do 4 in each, and then we can add those 4 together to get our final answer. So it's 3 times this mess. Well, the first one is negative 1 choose 0 times x to the 0, plus then we have negative 1 choose 1 times x to the 1, plus then we have negative 1 choose 2 times x to the 2, and then we have one more term, negative 1 choose 3 times x to the 3rd, plus dot, 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 and that's that first one. The second one then becomes, well, we'll put it in brackets too. negative 1 choose 0 times negative 1/2 x to the 0 power plus negative 1 choose 1 times negative 1/2 x to the 1 plus negative 1 to the 2, negative 1 choose 2 times negative 1/2 x to the 2, and I wrote too big. I'm so sorry. We're going to solve that problem. Thank you, Notability. And then plus negative 1 choose 3, negative 1/2 x to the 3rd plus dot, 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 close those brackets. And that's what we're looking at. That's what we're expanding. Okay, and so when we do, I think that I didn't write out those steps exactly, but keep in mind, so this is 3 times, and that very first term is 1. Anything to 0, there's one way that happens, times 0, x to the 0 power is 1. But then the next one, this becomes a negative 1 divided by 1 factorial times x to the 1. Then we have negative 1 times 1 less than that, which is negative 2, over 2 factorial. So notice when we have 2 terms in the top right here, and then it's 2 factorial on the bottom, and that kind of follows that pattern. When we have 3 terms, we have 3 factorial on the bottom. Go back and watch that video as to where that part comes from, because it's kind of cool. And then we have a negative 1/2, where did I go? Negative 1/2 x needs to get squared at this point. And then the last term becomes negative 1, minus 1 from that is negative 2, minus 1 more is negative 3, all over 3 factorial. Oh, that's going to cancel. That's nice. Then we have negative 1/2 x to the 3rd power plus dot, dot, dot. That's the first part. And then all of that needs to get added to, I thought I had all this room, or I didn't need, anyway. The next one is 1. And then I have plus negative 1 over 1 factorial times negative 1/2 x to the 1 plus negative 1 times negative 2 over 2 factorial times negative 1/2 x squared plus negative 1 times negative 2 times negative 3 all over 3 factorial times negative 1/2 x cubed plus dot, dot, dot. We're going to close our parentheses, our bracket there, pretend. Well, you can't see it, but I did. This is the next problem that somebody had a question on. And so we need to clean up all of this mess and to get to our final answer, which, pause the video, try to get to the final answer. I am running out of time today. So the final answer, you're going to end up having this term right here. When you expand 3 times 1, gets added to this, which then gives you that 4. And then when you expand, then we have to do that same sort of idea. We have to say 3 times this mess plus this mess will give you the next term. Okay, and that next term would be minus 5/2 x, and then we have 13/4 x squared, and then we have negative 23 over 8 x cubed, and then it would keep going. And so that's how that works out. Then what did they say? For what values does it converge? Okay, so when we talk about converging, I said negative 1 to 1. Does that make sense? Oh, I think we would want to look at each one of these and kind of come back to, well, okay, the question was, when does this one converge? Well, here's what they tell us about converging. That the interval of convergence, so notice what I have here is I've got, that's not going to let me write on it. This is a geometric at the top here. For n is an element of the rational numbers, that top line. This is a geometric series. So a geometric series will converge if the common ratio is, the absolute value of the common ratio is less than 1. Oh my goodness. Which is what they wrote here. The interval of convergence, for which the expansion converges, is when the common ratio is less than 1. Which means that, then they manipulated that. That means that it has to be between a negative absolute value of a over b and the positive absolute value of a over b. So coming back, oh, there's all my pictures, lovely. Coming back here, it was, it's a plus bx to the 1/4 power. So the interval of convergence is, what did we say? It's the negative absolute value of a over b is less than x is less than absolute value of a over b. Or it's not b over a, I think it's a over b. Come back, where did it go? It's a over b, okay. Sorry, there's all of my clutter. So then my A was 1, so it's from negative 1/3, and my B, well, so it's from negative 1/3 to positive 1/3 in this particular problem. And that's how we think through that. In this one, it would have been 3 times, how does it, the answer that I wrote down was negative 1 to 1. But let me see if I can, okay, so A, I'm looking right here. A is 1 and B is 1, so that's negative 1 to 1. And in this one, we have negative 2 over. Oh, well, so if this, here's my thought on that, and I guess I should go think about this a little bit more. But on this one, if this piece alone gives us an interval of convergence of a negative 1 to is less than x is less than 1, and then the other piece, say it gave us a negative 2 to 2, well, in order for both things to happen, you need the smaller of the two intervals. I think that's what's happening, but let me think about that a little bit more before I say it definitively. Hopefully that helped a little bit on those problems. You got to practice. I have to practice. So I'm working through, maybe I'll try and finish that, but I'm working through the review problems. And I will post that for you guys when I get to a good point.